sent to you if you wanted it, etc. Right? So the first lesson, and I'll go very fast with this, right? So the first lesson, let me just get this on the slideshow, right? So the first lesson basically had a lot of small topics on the first lesson. Not too sure what that is, right? Right, so a lot of small topics on the first lesson. Small meaning like they were just, you know, a couple of slides long. And I think the first part of it, the first piece, would have been the main distinction between process safety and normal safety. And, you know, just to remind you of that, I mean, the main thing was that process safety more pertains to the industries. You have like the chemical industry, and process safety have to do with those events that they don't happen all the time. It's not like normal safety. Normal safety, you know, every day you go to work, you can find something that can trip you, something that can probably cause you know, slip, trips and fall, or there may be housekeeping issues. But with process safety, you find that the hazards, what they say about the hazards, and I'm going down here, so the hazards are really stuff that don't happen all the time, right? They say it is low frequency, meaning it doesn't happen all the time. But when it does, it tends to be more than like somebody slipping, tripping and falling. And in fact, the outcome is oftentimes death and destruction on a multiple scale. So process safety, and of course we had exams on these, exam questions. Process safety deals with stuff that doesn't happen all the time, but when it does, the severity is quite high, right? And of course, I think we all would have seen the explosion in Beirut. Now I do have the video. I don't want to show a video at the start of the class. I prefer to do some teaching. So if we are finished, and I mean, if I am finished and I have a couple minutes extra, it's about a 7-minute video. I'll give you a look at it anyway from CNN, right? So that's the idea of process safety, stuff that doesn't happen all the time, but when it does, it tends to be quite disastrous. And this was a question coming out of that anyway, right? I think as you all have, or you should have maybe pen and paper nearby. Let me see if someone is messaging. Sometimes people don't get the link. But again, I suppose if anybody, you could probably just liaise with Janet behind the scene. Yeah, I was saying, yeah, like if you have pen and paper nearby, you know, I mean, we are recording this, hopefully you have your handout. We do have a YouTube channel for those of us who know. I don't know if you all have actually visited the YouTube channel. All you have to do is put in Shadrack Safety Institute in YouTube and you'll find our channel. So you can write that down, and I would most likely post this video there so that anybody can go back and review it anytime. I say anybody because I have realized that we are getting likes from all parts of the world, right? From different parts of the world. When you put something on YouTube, anybody could see it anyway. Right, so if you haven't subscribed, you can do that. I mean, that'll help us out a bit. That helps out the channel in particular. And I think the last time I checked was 139 subscribers. So, and if anybody joining, it will be somebody from this class today anyway, right? So I was saying that anyway. I wasn't saying that to tell you the YouTube channel alone. I was saying that to tell you that, like I said, there's a lot of stuff to tell you where exam is concerned. But one of the things you should know is that NEBOSH is willing to give you the exam, right? So that's a plus anyway. We just have to work around, or not around, but we have to work with the ministry guidelines for your exam. And at the end of this session, I'll give you some ideas of how we can get that done. There's more than one way, there's more than one route to work with the ministry guidelines anyway, right? So the main thing though, just in case you were wondering, you know, like, and I think this is one of the reasons why we didn't restart the process safety somewhere in July, was that they were not willing to send the exam to Trinidad. They didn't set exams. They didn't have set exam dates, right? But as of September, set exam dates have returned. So it is just for us to work with the ministry guidelines. And like I said, at the end of the session, I would give you some suggestions. We could talk about it and see which suggestion best suits you at the same time, right? All right, so moving on. This was a question. Hopefully when I'm talking, you could have taken a read of it, but I wouldn't stop. I know we had done all these things already, right? Maybe we can do this one. Process safety differs from personal safety because it protects public only and all industries, public only and process industries, workers only and all industries, workers, public, and process industries. So perhaps the best one would be D-Day. And that's the fun thing about multiple choice. For those who forgot that, you know, all the answers are looking there at you. Again, if you have forgotten these things, and you have that pen and paper nearby, again, you can just remember it is 40 questions, 40, and you are required to get, I mean, if you get 24 correct, you pass, right? So that means you have a good amount of questions you can safely get wrong and still be awarded this certificate. So 24 out of the 40 will give you 60%. And of course, people have scored, I mean, I have not had anybody who scored 60 in this. The pass markers, I mean, the mark, people have been in the 90s, 80s, sometimes you find the odd 70s because it is that easy of an exam. Anyway, so I was saying, I'm not gonna go through all of the subheadings, I can show you them. So we had process safety leadership. That basically says the same thing for all safety courses, that leadership starts at the top, right? I'm going to leave that there. Then we had the management system. This was one, process safety leadership. And I don't know if anybody remember, you know, where does leadership fall in the management cycle? If you look at it, the management cycle is, it goes over the principle known as the Deming cycle, which is the plan, do, check, act model. And so we talk about leadership, and this is multiple choice, of course. So where does the leadership fall? Does it fall within plan, do, check, act, or do you remember where we had said that it will go? Leadership fell where? Anybody?
I think it's do.
Say?
Do.
In
Okay,
the middle.
okay. Anybody else?
In the middle.
In the middle, very good, yeah, Jameson,
Okay.
right? So I think I make out your voice, right? Yeah, so leadership, if you didn't have this highlighted as yet on your diagram, you could just remember to put in leadership in the middle there. That's why they say safety starts at the top and it's central, and all of this is talking about that leadership is at the heart of health and safety, right? Anyway, as we on this, you know you have to know this chart. Again, seeing that this exam is going to fall in October, you know, and it's going to be way beyond the 28 days anyway, you know, I mean, you have some time, right? And this is multiple choice. I wouldn't really say go and cram. You don't really cram for multiple choice, but you should know your work and you all seem to remember some of it. But they do like this as a question. From sit-in to sit-in, they give you this and they ask you like, where does policy fall? In fact, I'll show you the question now. Where would reviewing performance fall? And by the way, it's only one they'll ask, right? They have asked plan before, they have asked do, they have asked leadership before. So anything could come anyway, right? I think I have some questions hidden up somewhere here. So remember, the aim of all of this is that leadership is central to process safety management, as it is, I think, to all safety management. So you have one here. I'll just, in fact, I have another one. Let's do this one, right? So that one, I remember doing this one in class, so I might as well do a different one, right? So the key elements of a process safety management system follows the plan, do, check, act model. Policy aligns itself with which part of the model. So it couldn't get easier because that is like the first one. Policy is plan, right? And you know, like I said, I am given some hints for the exam. What I mean hints, like strategies. I was saying now that I would all combine these strategies at the end of today's class and tell you how we can go about to get the exam done. So one of the things I mentioned is that NEBOSH is willing to send the exam. The other thing is that we could work with the ministry guidelines. The other thing is that the paper has 40 questions and the questions are this easy. No one stays in the room for the entire hour. I've never had anybody that stayed for the whole hour. People are able to finish this in half an hour, 15 minutes. And because of those pluses, then I think we can work with the ministry guidelines. And like I said, I'll all merge it to the end and tell you some strategies of how we can get this exam done in October with less than 5 persons in a room, right? And it is more than achievable when I tell you at the end of the class. All right, so back to here, we have the significance of learning lessons from actual or potential consequences. Now, again, I'm just explaining, if you were here for this, the idea here was this, that organizations in this field of process safety, they have to learn lessons from past occurrences. You see, the reason is because you can't wait then for one to happen on your site. right? Unlike normal safety, like normal everyday health and safety. When I say normal safety, I'm talking about normal safety officers, right? Like they can like they can go to work, and during the course of the day somebody complains about noise, and they complain about maybe some sort of odor, some sort of gas at the company that they're picking up, maybe a faint hydrogen sulfide. And I mean, those things could be, hazardous in themselves. Of course, they are called hazards, but what I'm saying is that they are not disastrous then. So in the world of process safety, what they say is that you have to learn then from the past occurrences. We have to learn from Beirut. We have to learn like what went wrong then, right? You have to learn, because you cannot wait for a process safety accident at your site to deal with it, because like I said, it will be disastrous in the terms of deaths, disastrous in the terms of destruction. So you had some past occurrences here. You have Union Carbide, you have the BP Texas oil refinery. I think we had looked at the video for this. As I mentioned, I do have Beirut on right next to this video format here, but I don't want to share it as yet, because I think we can get some content moving, right? Chernobyl, right? We spoke about that. And if you wonder, I mean, if you forgot what this is all about, this was in a company, right? They can look at these past disasters and they can take what is called the lessons learned. So the lessons learned out of Chernobyl was to tell the truth, which we know that they don't do, right? But I mean, this is the lessons learned. The lesson learned, and like for Trinidad company, was that if there was a spill, tell the truth then. Tell the truth then to the members of the public. Don't hide it from them, right? A lot of the deaths you had here was because of they didn't inform the members of the public. The same too was in Bhopal, India. There was a release of a toxic gas, and they didn't warn anybody about it, right? So that is what we mean by organization learning. And there was a question on this. The question, I think this was one we did many times, but I repeat it anyway for the sake of bridging that 5-month gap, right? The most important benefit of worker engagement when undertaking risk assessment is the avoidance of conflict when risk assessments are introduced. I'll give you one to do in a bit, but like I said, I want to put some content this morning. A balanced representation of worker and managers, compliance with legal requirements, and D, a detailed knowledge input regarding practical workplace hazards and risk. Again, from this, the best possible answer would be D, right? D. And I do have some new questions, but again, I'm going to leave them almost at the end, right? Reasons for accident investigation, it is the requirements of the law. And like I said, there's a lot of small topics here, which I am going to try to end off within a couple of minutes, right? You do have things like, again, the need for sharing lessons learned. We have them written down here, right? So we have here, again, you have things like the use of benchmarking is going to come up in a bit. And benchmarking is just comparing your company's standard against another standard or a better standard to see maybe where gaps exist in your company, right? So a lot of fun reading. When I say fun reading, is that it's not difficult on the mind and it's not difficult on the brain at all. The purpose of benchmarking, to get best practices across different organizations. You have management of change, which is actually a form that is to fill out whenever you have any change that is not a normal change. I could probably take a read of that somewhere, right? So if you have any change that is not a change that occurs then like at the end of the year, or one that is required by the manufacturer. So it actually includes all modifications to equipment. If you change a procedure before it was meant to be changed, if it wasn't time for the document review, a change of raw materials or any processing conditions other than what was just the replacement in kind, or what would have been a typical replacement, you need to do a management of change. And for those of us who have done that, just in case you forgot, that is actually a form to fill out, and the form would then be incorporated with the change, right? So if I can just, I was adding someone in the background there, right? If we can just get that slide to move, you'll see it. So you can take a read of these. Like I said, it comes down to a form, a management of change form, and the person responsible for the change must be documented on the form. We had, I think, worker engagement, which I think was self-explanatory, that you need to engage workers in decision making and all of the benefits for that. I don't think this was complicated in any way. I think that's the same exam question there. The use of contractors, the process of hiring contractors, and that is also going to be in today's lesson a bit. And the end of this would have been something called competence, and how do you train operators then, and even all of those of us in process safety, how do we train them and how do we identify a training need? Those of us who have done this, and I remember this, the answer was something called a training needs analysis. And what they did here in this course, they referred to it as a process safety competence management scheme. That's what you'll see up here, PSCMS, a process safety management competence scheme. And just for those of us who, like I said, are not in process safety, all that is, it is a training needs analysis. Let me show you the picture of what it looks like. A training needs analysis is like every company does one. They would have your name. Of course, I have the position here. There's another one, of course, right? And there's one in your book. So they will have the person's name, position, and they will have what skills you came in with, and then what skills they want you to gain, again, maybe during the course of a year per se, right? So again, you know, as how process safety, this particular course is quite popular with NEBOSH around the world now. So somebody may have done like City and Guilds, and then because of these courses, it would have been highlighted that they should have probably done, you know, process safety management. So then, you know, they recommended then for the year coming ahead that they do this. Right here we have level of competence, and this is just the idea of a training matrix. I mean, the thing is, remember, this is a multiple choice exam, so you don't have to explain, or you don't have to, you know, draw no matrix for yourself. There's a question in this, which is right here. Workers competently perform a routine task on a process line. A new process will shortly be introduced. Still trying to add someone, right? That requires many different skill sets. What is the best way to help with planning to fill the skills gap, right? And of course, we never talked about anything like psychometric testing here. Only thing we mentioned in this course is something called a training needs analysis. Or if they were to change this, they would use the heading PSCMS, process, you know, safety. What the meaning of it? Any process safety management competence scheme. But you get the idea that it is some sort of mapping of the person's skill with what they have and what they have to do again. And that was the end of this session, right? If Janet is on, I know she's on, I guess you could probably try to liaise with Giovanni. He seems to be trying to contact us and trying to log in. But I have clicked him about 3 times now, but he's not getting in, right? If we could try to liaise with him on this, I'm not too sure if he's getting in at all, right? So I've actually done it 4 times now.
Connecting with him though.
Say it again?
I said connecting with him. I just saw the audio was connecting.
Right, it's just connecting. I'm not too sure what's happening with him in the background there, right? Anyway, all right, so that was the end of this review. Like I said, I think, you know, with exams being carded for October month, and that is more than, I guess, 8 weeks away. You know, it will be up to you all to read that read the handout over. I mean, it will go up on YouTube, so you can simply just play it over. It was a review, by the way. It wasn't a full class. You notice I did go a bit fast on it. And you can read the book. I mean, the book is such a thin, I mean, this is relatively a thin textbook, right? Compared to the other NEBOSH books out there anyway, right? So, you know, I guess to keep yourself occupied when you are home. I mean, for those of us who have, you know, at least you probably will be home a little bit more now than before, right? You know, it's still a good idea to take a read of it. And I mean, you would ace the exam. I mean, we have had the most amount of time to do this exam as people in the past would have had to do it in just 6 weeks. We are literally taking a whole year, as the old people would say, a whole year to get a 6 weeks course done, right? So let me change the view there because I have, there was another PowerPoint. So this is the one that we are on now. If you have any questions, you can ask as I'm changing PowerPoints there. This was the second PowerPoint. And we have just made it in half an hour. So that was good. I mean, a review of the whole first lesson in half an hour time. And this one, I would also do a review, and then this would actually bring us back up to speed with today's work as well, right? Any questions from anybody so far? So far, so good. All right, but this one I would ask you some questions, right? I wanted just to finish up that first one there, right? So you have a chance, I guess, to see some stuff in this one, right? So I want to go back to the first slide again. If you have your books, and we all should have our books. You know, the books had come that Sunday that you all supposed to get it anyway. And I know some people, I know Indira and Sharon did come by and collect theirs, right? I mean, if you have not collected your book as yet, I would be in office tomorrow. I think Janet will be out. I would try to be there, right? I'm not gonna stay there a whole day though, but I guess if you're coming by, you can let me know. I'll probably be there around maybe 9 to about 2. So you can come by and pick up your book. I know Jerry Adams came by, I think was it Friday, right? So you're entitled to your book anyway. So if you didn't pass by as it, and if you have the time, and I guess, you know, I think it's safe, and most people are still, you know, as long as you don't congregate anyway, right? You take all the recommended safety measures and wear your mask and whatever have you. You know, you can pass by and collect your book. There isn't a whole crowd by the office, it's just me anyway. All right, so this would have been chapter 2, right? So I think we were in 2.2, but again, maybe to bring it up to speed, we had mentioned the reason for having a management system, and we actually just looked at it in chapter 1 there. The management system followed the same PDCA cycle. For those of us in safety today, there's a proper name for it. It's called ISO 45001. So you can mark in that. You know, I don't know if they could ask you that. Instead of saying PDCA, they can say ISO 45001. What you have to know, it's not a different thing though. What happened is that the PDCA is actually a principle, right? The PDCA is not, yes, we draw it as a cycle answer, but it's really a principle that you find all management systems having. So to explain that, not that this is exam, but to explain that ISO 45001, it will have a policy, right? So you'll find the principle of PDCA is intrinsic then to all management systems. All management systems will have a part about measuring performance, right? Possibly via audits, if you want to say that word anyway, right? All management systems will have a place for reviewing performance, learning lessons, and continual improvement. So when you say, you know, for those of us who know how to really properly say this, PDCA is not really a management system, but PDCA is the principle by which the management system is based on. I think I have it here. The model of management system is based on the idea of continual improvement, right? It's based on a principle to what we call the PDCA cycle. Nonetheless, that's what they were saying, that, you know, process safety management must also be managed from a management perspective, and it must be then integrated into the process safety management. And this is what we come into now. What we were coming to in that second day was that the idea was that just as how all companies will have a policy for everyday safety. I mean, you go to any company, you even go to companies that are not industrial companies. You can go to TN Tech. These are the places people go, I guess, these times anyway. You go to Flow, you go to the bank, you normally find that there is a policy statement, really just where the customers can see, and it will say something like, you know, we at Flow or we at Scotiabank will be committed to your health, safety, and welfare. And, you know, all of the good things. Of course, you see in those things now, things like wear your mask and stuff. So this was the idea, that the idea was, if I didn't distract you there too much, was that for the process plants, for the process companies, they needed to have a policy as well, but one that was more geared towards process safety. So that policy, they refer to it as a MAPP policy. seeing that process safety deals with things that are severe, major, what they required companies to have was a policy, just like we have the normal policy displayed throughout all companies. Those process-driven companies needed to have a separate policy that would have highlighted major accidents and how they would prevent those major accidents, right? So just if you can go back here, but you would see that if we apply this to process safety now, you'll see that when you say plan and you say policy, it means the companies, the Atlantic LNG, the Nutrien, the Methanex, they must have, you know, a MAPP policy highlighting what are the major accidents at this plant, if it's a blowout, a gas release, and then how would they deal with it. And that particular policy is called a MAPP policy, right? So just to kind of go down a little bit more because in fact, there may be an important line here. So sets out the operator's overall aim and principle of action with respect to the control of major accident hazards. So this policy would not be addressing things like slip, trips, and fall and housekeeping as if that's your normal safety policy. This is a separate policy that is going to deal with, it's actually better said on slide here, a major accident prevention document is similar in approach to a health and safety policy document, but with two important additions. It must deal specifically with major accident hazards, and it must include measures to protect the environment. So I think that is noteworthy of being learned for exam. I mean, it's a fun multiple choice question, you know, how is a MAPP policy? I guess even if they say MAPP, they might not have said MAPP, they may have just said a process safety policy. How is that different from an everyday policy? It must, you should figure the first part. The first part, it must include, you know, that's what we're talking about for this whole class, major accidents. The second piece though is that it must be able to protect the environment as well, right? So we did that, and I did that extensively, which I'm not going to do over. I did it extensively here where I listed out for you what could be, well, what are all the ideas of a MAPP policy, and all of this, in case you're not seeing all of this, I was saying that for that company, if I can go back, for that company, they needed to address all the elements then of Plan, Do, Check, Act. They needed to say what is their policy to prevent a major accident. This year, they needed to say how would they implement the policy, how would they measure it, for example, like probably doing a drill, training, etc. Right? What lessons would they learn if they do those drills and they do those audits on their system, and how would they take it a bit further, right? And so in the slides, remember I told you all the long story that we wrote this slide before NEBOSH had a textbook. So you find the slides, if you take a look at the slide, it's more detailed than your textbook. I think when they go to put a book together, you know, they try to keep it down to a certain level anyway. But I've been very explicit here when I went on to tell you what would be some of the things they want to put in the policy. Like they want to put some active monitoring aims for those who know about performance indicators, and then some reactive aims as well. And I'll address the reactive in a bit. But the active aims you want to put in is things like, you know, have they captured any management of change on the form? Did they have anybody trained? And of course, for those who know the heading here, leading indicators mean that these are proactive things the company wants to measure. For example, mechanical integrity, asset management, right? And then I think the big no-no is the reactive indicators. The reactive indicators are the lagging indicators. Remember, you can't wait for an accident like normal safety now. You can't wait for like an incident or an accident to say that you want to learn from that. So the reactive indicators are a little bit tricky. The reactive indicators is that you do have to take anything that then falls anything that falls beyond a specification for process safety, you have to take that then as your potential reactive indicator. You can't wait then, right? If something like if a valve didn't work how it's supposed to work, if a particular reading on that valve or the gauge was supposed to be maybe 100 parts per million and it went to 95 parts per million, even though it didn't result in anything, you have to take those things as the reactive indicators because you cannot wait for, you know, a full-fledged accident to learn from it. So I have some here, some of the process safety near misses that they can put in the major accident prevention policy. So they'll have to say things like, we are committed to, this will be in the aim of the MAPP policy, we are committed to ensuring the highest degree of inspection and testing for parts and equipment, right? We are committed to preventing things like process deviation or excursion from recognized standards. So you have to be a little bit more refined with your reactive indicators of process safety as, like I said, a result of it being, you know, brought to life then would result in a full-fledged accident. So things like the failure of a valve to open or the failure of a valve to close at a specific time or in the required time, all of those are the things you have to take into consideration. So these were these slides have in it. I went on to list them. All of them, they are here. You know, when I think we taught this in class, I told you all don't learn, I mean, you can learn one or two, but the thing is you just have to know that the process safety reactive indicators is stuff that falls, you know, like below specifications. If you see it for an exam question, not that you have to remember what I put here, but you have to remember that something was outside of a design parameter. Or something was then, you know, it failed. You know, an instrument failed and, well, not really failed, but maybe it didn't operate the time it's supposed to operate in. There was no accident, but again, that is your reactive indicator, right? So I went until there's a whole bunch there and more on this side as well, and more on this slide as well. So you can take a read of it, right? Relief devices that fail bench tests, interlock test failure, right? And it just went on and on, like I said, to give you a lot of stuff that is, you know, like, I mean, if you wasn't in process safety, you may actually ignore some of these things. And like if, okay, like for example, the development of ROS, you have it here, ROS and scale. If you were just in like a normal plant and, I mean, a normal company and they had like a tank storing water and there was a little bit of rust or moss on that, you probably wouldn't bother with it too much. But if it's a process vessel, if it's a process tank, well, then that's a serious, you know, reactive indicator there. And so this is the idea behind it. You can take your time and read it. I think I'm remembering something for exam. I think somewhere in your book now, if you have to bear with me because I have to look for it. I think in your book, this was a question, right? And they had asked for, you know, like you saying which was a reactive and a proactive indicator. I have my book here, right? I'm trying to get the page. And I think one of the things they have was the word, the number of, right? So in order then, trying to find the page and talk at the same, I guess in order for you to say something was reactive, you had to say like a high number of interlock test failures, right? Maybe if you have your pen, and I know you have it, you can take a little note of what I'm talking about. Should I not find it, but I did find it, right? So it's on page 29. Just take a note if you don't have your book too close to you. Page 29, the right-hand side of the book. If you get into that now, you'll see what I'm talking about. It's not just to say things like relief valve failure, and I don't think they'll put it like that, but they will say like a high number of this. For proactive indicators, they say percentage, right? So remember the trick with multiple choices that it is a trick, right? It is multiple choice, so they tend to be tricky. And I remember here they had given a question, can't remember the question, but it had the word a high number of and a percentage of, and you had to pick which would have been reactive or which would have been proactive. I can't remember which one, but the thing is, did we find it in the book on page 29? If not, I guess, yes. Okay, right. So you'll see what I'm trying to suggest, right? Well, not me anyway, the past paper, but I'm trying to lead you back to that past paper, where for lagging indicators, if you look at the word, they say in number of unexpected loss of containment, a number of loss of containment, number of fire or explosion, number of fire of explosion again as a second line there, number of incidents. But for leading indicators or for proactive indicators, they have percentage of safety, that's twice. I'm not echoing. Percentage of maintenance action, percentage of fault trending carried out to schedule. So I think that question had asked, I mean, like, I think the point I'm trying to suggest, because it's multiple choice, if they say they want um, lagging indicators, you have to look for the answer that says a number of. And if they want proactive indicators, you have to say the one that says a percentage of, right? At the same time, try not to confuse you. Remember, when I was like this, it means I am remembering questions. There was another question that had a trick in it similar to that as well. I think the trick was, listen to what they did a year. It had it had a sitting that they had asked for. Again, it had to be one out of the two, proactive or reactive. But the only thing proactive in it had a number of. So that was funny compared to how it's taught in the book, right? In other words, then they asked out which of these would have been proactive, and every answer had things that was reactive. The only one that had proactive, like training, would have said the number of training, but then based on your book, number was meant to be reactive. I think the point of this story is that you have to use common sense. At the end of the day, the book is the book, but you must know that training is proactive, right? So you can't, you know, as you old people, they say, book sense and common sense, right? So that is another sitting where they tried to trick the students, right? Where the only thing that was correct was training, but instead of having percentage of training, and I remember some people came and they commented on that, it actually had the number of. But the point of the story I tell you is that don't let your common sense go out of the window then. I mean, training is often seen to be positive anyway, right? So I did pause there to share that, and I mean, I covered two past paper. If you all could just make a little note of it, because I know Janet emailed some past papers, or I think she did. If not, we will be giving you all that in the weeks coming, so that we can have a look at those things anyway. But I mean, if you have your pen and paper, please just write it down. That was a two past papers, two tricky past papers that one just asked, you know, lagging and leading indicators, and which you had to know, for example, number and percentage. And then there was another one that twisted a bit. And the only thing that was proactive was training. But instead of saying percentage of training, they had number of training. Some students didn't put it because they felt number was meant for reactive, which is how the book have it. But then, you know, common sense, I guess, will tell you that training is, if everything else would have been a valve failure and something beyond a process parameter and maybe some gas release, you must know that those are reactive, and the only positive thing there would have been training, right? So in all of that talking, I did pass a question, but I'm not going back to it because you know, I think you all could often just turn the page back and get that done, right? So here we have a bit on auditing. How would you maintain process safety standards? And as you would know, or you should know, those things we just finished there, those reactive and proactive indicators, they are called in the company KPIs, key performance indicators. In fact, the word indicator would have been said in this as well, right? I'm trying to go back and show you, but I know you'll find it, right? The word indicator would have been said there all the time, lagging indicators, right? So the part that those of us in safety know that every month we have to compile those statistics, and then those statistics is normally shown on a spreadsheet, you know, like how much hours you would have completed in training. And I use in process safety now, how many MOCs would have been, you know, done, how much safe shift handover would have been done, the reactive indicators, was there any process that went beyond its parameter, was any valve found to be slightly deviating from how it's supposed to function. And those things is captured on those spreadsheets. It is really a spreadsheet. Some companies require that you put it on a graph. And then what they will do, those things are subjected to audit. So how do we ensure that if something was captured on those key performance indicators, yes, the managers could, take a look at it, but how do we even ensure on a bigger scale that those things are done? The answer would, of course, been things like audits, right? Compliance audits, etc. All right, so from here we had gone into, and I'm going to go a little bit fast and then slow down a bit, right? So from here we had done the risk management techniques in process safety management. I'll go a little fast here because we did cover what a normal risk assessment is all about, the 5 steps. If you are in safety already, you should know this. If you don't know it, I don't think you have to learn it for this exam, but you may want to learn it for everyday life because this is what safety people do for a living. We do risk assessments for a living, and the headings you see in here, step 1, 2, 3, 4, 5, would be the headings on a risk assessment form. So you can't get away from this if you're in safety. You can get away from the exam because I don't think this is going to come for your exam. It's two level 3. It's level 3 when our course is level 4. But you can't get away from it if you don't know it by heart as yet, in that you would see it on your risk forms. The first thing you have to capture on a risk assessment, deciding, of course, what is the task and who doing it and stuff, will be what are the hazards, who can be harmed. The same thing you find here, right? So let me just explain the moral of this story. The moral of this story was that they were saying that we have to do a risk assessment. It was a requirement of the law. You can find it right in the first couple of slides, right? You find it here, regulations, straight to the down, I guess to the bottom here. There's a UK law there, the Management of Health and Safety at Work Regulations 1999. You don't have to learn it by heart. The point is, doing a risk assessment is a part of the law. And for all of us in Trinidad here, and I guess wherever this video may end up on YouTube, risk assessments are part of any law in any country. Once your country has a law, if it doesn't have a law and you follow the ILO standards, it is the same thing. In Trinidad and Tobago, it's in Section 25, you'll find it to do a risk assessment, right, in the local OSHAC. Right, anyway, so the point of that, I was saying that you have to know to do it, and the moral of the story is that what they were trying to suggest here was that because process safety, look at right here, right, because process safety deals with, high severity occurrences, then what they were saying, I'm just trying to boil this down for you, was that a normal risk assessment is advised, but you need to do it in more depth, right? We need to do then a more detailed risk assessment other than just that 5 steps on a spreadsheet, right? Or on a table. And the 5 steps is quite detailed. I mean, those who know this is quite detailed. But in the process industry and the oil and gas industry, they are suggesting here that we do a more advanced technique of a risk assessment, and they had a bunch on your syllabus. I think we just had 1 done. You could try to, I mean, if you think I did more than 1, I can't remember doing more than 1. So we're going to review 1 now, and I'll probably get the rest done. And that will probably be it for the majority of today's class anyway. The majority, when we're still putting a little thing on
I
the
think last class we did 3. We did
really?
HAZOP,
Right.
Bowtie, and event 3.
Oh, well, we did the main one, so better yet, right? So good for
Yeah.
me, right? I'll just be able to review you with them because those are the major ones. I think that's why I may have hinted to those. The failure mode effect analysis, FMEA, is just like a HAZOP, and if I'm missing out one, that would probably only be it would only be something called a hazard. Those were the 5, right? And those are the easier ones. So I may have done that. So good, so that you were actually there, because I was worried. That is the hardest part of this course, to understand those HAZOPs and them anyway, right? Anyway, types of risk assessment, we were saying that there were about 3 types of them. You had qualitative, in which the risk is calculated by just saying words, like saying high, medium, and low. Now, if we did HAZOPs already, you should remember that a HAZOP is actually also qualitative. However, it's more refined in that it didn't just say high, medium, or low, but they went on to say things like, trying to see if you can remember, if you all can remember, but they went on to use guide words, right? And a guide word would have been a word like more, M-O-R-E, or less. And more means if they were looking at pressure, more would have meant an increase in pressure. If you were looking at pressure again and they said less, less would mean a decrease in pressure. The point of this story though is that they use words. More is a word, less is a word, just like high, medium, and low, right? You have semi-quantitative methods that uses numbers like 1 to 5. And we may have touched on the ETA. However, the ETA is not semi-quantitative. The ETA is completely quantitative, meaning that it's very refined in that if we did it in class, the numbers would have been like decimal points. If you look at this little slide, they said it uses, well, yes, numbers, but it uses, modeling, calculations. If you look at this in the book, they mention things like it uses something called binary logic. It's actually on this slide, but I'm on this introductory slide, so I'll just say it uses binary logic. Binary is just like probability, like matrix, like zeros and ones, right? And so you want to be very precise. You want to say like 0.866111, right? Now, when I say you want to do that, it don't mean you have to do this for exam. There is more to this. We have a popo crying, right? All right, let me just, right, so, trying to see who it is. Okay, you can probably just mute your mic. You can probably just mute your mic a bit. Like I said, kids are fine, right? I have two myself, but at least they, thank God, they're out of the stage of crying. So what I have to do is put on a game for them to play next door, and they will be with that for the next couple of hours or so, right? But kids, like I said, are quite okay. I'll address some of this, like I said, at the end too. That it is okay, even for exams. You'll see what I'm talking about, I guess, at the end, right? So yeah, I was saying the point about that was the thing about words, and quantitative just uses the numbers, and I was saying that that the moral to this is that if you use numbers that are that refined, 0.81166, the thing is your risk assessment will be more objective. You see, if you say the risk is high, or even if you use a HAZOP and you say, okay, the temperature is going to be more, M-O-R-E, more, but then how much more? You're not quite being too specific when you say things like words then, right? So the thing I want to tell you here is that remember, this is still a multiple choice exam. So I think they have asked before, like, which is the best method or which is the best technique then for doing a risk assessment for the process industry. If they give you the option to say qualitative, semi-quantitative, and quantitative, the best answer will be quantitative. If they call it by name, as well, Melanie, who spoke before, I believe, if they call it by name and you remember the names, which of the following is the best, to use in the process industry? A HAZOP, a hazard, FMEA, all of these, if you look at the heading and top, all of these are qualitative, right? So when you're studying for this exam, this is the fun thing about multiple choice. You don't have to go and kill yourself there and try to figure out, like learn the slides by heart. You just have to understand what this slide is kind of saying, right? I have seen before, in 2017, just one sitting, right? The first ever process exam it had outside of the UK was right here at this school, Trinidad and Tobago, right? Right here in Trinidad was the first process exam they had, beside in the UK for 1 year, right? 1 year it ran in the UK. In that one sitting, and only in that one sitting, they had asked students, what is the meaning of the term HAZOP, right? And remember, it's multiple choice, so the words were right there. Hazard and operability studies, right? It never came back. I'm just trying to tell you, in case you want to know how much to learn then, it never came back to say that they repeated that question, all right? Anyway, I was saying, if they had given you the same question, like which of the following techniques would be the best, suited to the process safety industry, and you remember, all of these are qualitative: hazards, HAZOPS, Bowtie, FMEA, what if analysis. But you remember the ETA and the FTA. Now, we didn't cover the FTA, but I don't think it's in this course. The FTA is done at the diploma level. But remember these two, and the one they have brought before is ETA. Remember that this one is, more numbers, it's more accurate. If you look at it, say it's more objective, right? Then this will be the answer that you want to go for doing a very precise risk assessment, right? At the end of the day, multiple choice may be tricky, but the thing is the answers are right there looking at you once you have a basic idea of what you're looking at, right? So I want to go down. I'm just looking at the time. It's about 11 o'clock, right? Right, so what I think I will do, 3 minutes to 11, I would give you a break, right? You can take a 5-minute break. Like I said, I do not recommend that you log off. I would stay right here for a while. I'll probably just go and check on my sons and I'm next door, right? But I'll stay here for a couple of minutes if you have any questions. You could just, if you leave your camera on, you can just go get your water, whatever have you, and just take a stretch, right? And we'll come back just about 11:05. But I'll be here anyway. I'm just there for just 1 minute or so, and we'll take it there, right? So let's get that done now. You can take a little impromptu break. I'll stick around a bit if anybody wants to have any questions answered. I know there may be a lot of questions, but like I said, we'll take it one day at a time, right? In terms of the exam. And I have addressed some of those issues anyway, right? So yeah, let's take that break now. And I guess you could chat. I mean, the thing about Zoom is that you could actually chat amongst yourself at the same time, right? So I think what I'll do, if I stop the recording, it wouldn't be able to restart, but I may be able to pause it. So let me just pause that and I would restart. So we were discussing the different types of risk management tools, and we were discussing, right, well, the HAZOP in particular, right? So we said before that it is, well, first of all, for exam, you have to know the meaning of it. At least one time in 2017, that question came, what is the meaning of the term HAZOP? I'm not going to go too much into this because we did it. It is a qualitative process. I'm going to go straight down to what it looks like. Let's make that slide to move, right? So, we did mention, I'm going to skip all of these and just show you the last part of it, right? That it uses guide words, and you heard me mention words like more means a quantitative increase, less a quantitative decrease, and to me, you don't have to learn these words, but know that it uses guide words because you are doing a multiple choice exam. With the exception, I think, of anybody who wants to go on to do the degree. Melanie is in the NEBOSH Diploma Level 6, and Unit A, you have to physically do a HAZOP anyway. But for the rest of us, we don't have to worry about that as yet, right? So this is what I wanted to stop at. So, I mean, if you look at this or any one of these charts anyway, you can have an idea what a HAZOP is. It follows some deviation. Sorry, there, my mistake, clicking too fast. Deviation, right? Like there was no flow. So if one of the words you're looking at was flow, but there was no flow. If you're looking at pressure, the pressure was high, right? Then you have to say like more, the word they use is more. The cause of the high pressure, the consequences, the safeguard, and the recommendation, right? So it isn't that hard when you think about it. Again, keep in mind you are doing a multiple choice. So, I mean, how could they bring this? It's not as if they're asking you to draw a table and do one. They may simply say, which of the following techniques uses guide words? And the answer will be HAZOP. Which of the following techniques uses a qualitative means of assessing risk? Is a HAZOP. The key thing about a HAZOP though is that it is predictive, meaning that it could be used in the design stage of a plant. The design stage means that the accident hasn't happened as yet, right? So it is best used at the design stage or whenever you have a plan modification. So you think about, well, if you change this valve, what would happen if the pressure increases on the plant, right? So this is the idea behind it. And as simple as that, I believe, could be your exam questions. But this one, the other one we did not do, hazards. And again, like I said, the reason for this is that this is even simpler than a HAZOP. So if you, let me just do the explanation first, and then I'll just read a couple of lines. So you'll see it is the same thing, right? So in a hazard, a hazard is used at the design stage, just like a HAZOP. But what a hazard is, right? It is like a list of the hazards. The company, safety and process manager, etc., they would have gone through already and just walked through the whole plant or a part of the plant, and they would have already gotten the hazards and put it on a sheet. What a hazard is, what a hazard is that you just have to look at that sheet, and as you do your inspection, you just tick off the hazards that they have already thought about. So if you come down here, you'll see that here, each area of the installation is considered against a checklist of hazards. So as you go, there would have been these ready-made sheets. It's not as if you have to go and calculate anything. You would go through, and if you're looking at a system of valves, you would see, are the valves of good integrity? Yes, no, replace. If you're looking at a gauge, is the gauge within, is it working properly? Yes, no, replace. You know, like, is the needle within, and they may have a range, like within the safe operating limit? Yes, no, replace. So that is what a hazard is. It is really the brainstorming piece here. On top here would have been what would have been done by the team to make the checklist in the first place, right? So it is a brainstorming technique by a team, which is very similar to a HAZOP, but unlike a HAZOP, it's just a sheet you're walking around with. If you know what a checklist is, if you don't know what a checklist is, you could just remember, you know, like whenever you visited the mall and stuff, you'd have seen, you know, they would have had Subway, and they would have all had like what they would have checked out for, like for the data, and it's a checklist just to take. That is essentially what a hazard is, right? So that was one of the main reasons I told you I left these simpler ones out, because there were not a lot of questions on them, right? This is something that I borrowed from one of our partner schools, Shields. So you could walk through this if you wanted what a hazard process is, but it was not part of your book. As I said, the PowerPoints were first, and then that was boiled down into your book anyway. A comparison between a hazard and a HAZOP is done on this slide very well. None of these has ever come for exam, but we could run through them as we did not do this before. So let's go with the one we know, which is the HAZOP. A HAZOP is systematic. It's done at the design stage, right? Those are the things we know. A HAZOP uses guide words like more, less, no, and reverse, whatever. We all know that. Does not typically assess risk. So I don't know if you realize that. If you want, I can go back and show you, right? A HAZOP then did not assess the risk, right? If you go back to what this is a HAZOP sheet, right? Now, when I put risk here, it is me then. I am the one that put in risk here. But a typical HAZOP does not assess the risk. If we go back, a HAZOP follows through these words here. You have the guide word, the G is guide word. The D is deviation. If you check it back on the table, you would see it. Oh, by the way, you have it in your book. Instead of going back and forth, you could just open your book and you would see a typical HAZOP. That one that I put there, again, that is me, right? That is me being, I guess, technical. Page 38 has a picture of the HAZOP as covered in this course. Now, when I do these, and you know, I did do this, and I do these for companies, I tend to put in the risk. But like I said, that is me. That is not, you know, the theory then. I put in the risk because for those of us in safety, like I fail to see what is the point in putting the hazard, and here put the risk. But if you look at your book, if you can do that with me now, page 38, I was telling you all that a typical HAZOP follows the heading of guide words. That's the G. D, deviation. P is possible cause. C is consequences on page 38, and the A is action. So in reality, accepting in my reality. Some of what I do for companies, right? So in reality, a HAZOP does not typically assess the risk, right? I have kind of done a one-up on the HAZOP to make it assess the risk in my chart there, right? It requires process and instrumentation diagrams, yes, because you want to figure out, you know, like what would happen to the temperature and the pressure. A hazard, what we just covered today, it is systematic, it is done by a team, we kind of mentioned that, but a big difference is that it does not use guide words, but it uses a checklist, right? A checklist. And with a hazard, now you have this in your book, if you look at the other page to page 38, page 39, you would see a hazard to the bottom of page 39, and you would see, yes, they did consider risk. You see in consequences by frequency. So assesses risk associated with hazards identified, and it don't really need, well, process and instrumentation diagram, PNIDs as they call them, right? Right, so I'm sure you're hearing the dogs in the background there. The dogs in San Fernando seem to be giving some trouble outside. All right, so not that I have seen this, I was telling you all, but I mean, it's a good thing we use the book there, page 38, page 39, so you can clearly see what the diagram had in it. I think we may have overdone this because, you know, there are no such comparison questions as yet, right? The Bowtie analysis, now you also, we covered this too, so I just want to show you it then. I'll show you it and discuss it. So our Bowtie analysis starts off with the event, right? You start off like with what could go wrong. That may be not a good example, but this may be more of a process example, right? So you have the influx of hydrocarbons, and with a Bowtie analysis, two things are shown. What is shown is the cause. Some people refer to that as the threats, and what is also shown is the consequences. I want to explain this, you know, I know 5 months ago may have been some time, so I want to go back and explain this a little bit. So what they say about a Bowtie analysis is that it actually captures proactive and reactive, you know, sides of what could happen here. On the left-hand side, I'm going to try to separate this here. On the left-hand side, right, which is this side here, the left-hand side, what is covered here is what could be seen as proactive. And if you wonder why, I mean, are they talking about shallow gas and lost circulation? Yes, they are. But these things here, anybody remember what the purpose of these things were? Anybody? It's right on the pity as well, so I kind of selling it out. Anyone have an idea what these things were? These kind of blank in between these lines?
Barriers.
Very good. These were barriers, right? So why they say it's proactive is that if they say, I don't know if you all know these terms, so I'll try to use one that everybody know. Well, kick is something in the oil field industry, right? So like if you say lost, let's say lost circulation or lost flow then, right? When they examine predictively, this is predictively, what is the cause, they'll actually put a barrier to it. So the barrier means that they were trying to stop that loss of flow there, right? So the loss of flow, and the thing is they can have more than one barrier. The more barriers they put, the more chances they are that they will prevent this from happening then. So then they said this is proactive because it really, we thought about it happening and we tried to prevent it if it did happen, right? And on the right-hand side, what they do here, they consider what are the consequences. So this side considers if the barriers fail and you did have a loss of containment, I'm saying containment and not circulation. If they had a loss of containment, they will try to predict that like a blowout environmental damage, but then they try to prevent it as well. When I say prevent it, they try then to deal with the consequences, not really prevent the consequences because it has happened, but they have a plan in place then. So if there is a blowout, what barrier will be put in place? This may be something like a secondary storage. This may be like, I don't know if you know these terms, but like a blow down drum, right? Some sort of, if you don't know that phrase, it'll be something to neutralize then the blowout, right? And in the world of process safety, we do have some of those. We have things like a rupture disc type vessel that will actually rupture on its own to let the pressure go out. We do have some videos on it. I can't remember showing you them, so I may take a note and show you them next week. But you have things like, you could think of them as neutralization chambers and neutralization pipes and pipe work then that they could direct a blowout to, like an increase in pressure. And those chambers and vats and silos, and those are using those words loosely because it is really scrubbers and stuff like that, that they call them, right? Flare stacks and your rupture disc systems that deals with that explosion. So it's dealt with, even if it is a consequence and the consequence is actually contained, right? So for multiple choice exam, they could ask you here, which technique examines the causes and the consequences of a hazard together in one, and that will be your Bowtie analysis, right? Which technique, I'm making a question. I'm not making them, but I remember in passing for questions, right? Which one of the techniques will consider both active and reactive strategies? The answer will be a Bowtie analysis again, right? And of course, having look at the diagram, you would realize why they call it a bow tie. They say if you were able, if I can maybe take it up the line, but if you were able just to draw some lines here, it looks like a gentleman's bow tie then, hence the name bow tie analysis. I think I have a past paper here. I'm not sure. I have to try to change this back into the cursor to get this to move, right? Okay, if not, there was a bow tie question, so I guess we would cover it when we started cover those past papers. I was looking there for it, but I'm not seeing it, right? Anyway, so let's just do the other technique here. And by the way, that was the question. I remembered, when I say remember the question, that was the question. The question was, which technique would examine both proactive and reactive indicators? And the answer was the bow tie analysis, right? But you also we covered this already, the ETA. Again, this was 5 months ago. To kind of summarize this, the ETA uses probabilities and binary logic. It is the most accurate method out there. However, right, the downside to an ETA is that although it can be used in the design stage, it is more accurately done after an accident. So that's the downside, that to get your precise actual figures, an accident has to happen. I think when we were in class, I mentioned to you all, this is like, you know, quote unquote, the black box of the plane.
Of the
Like
airplane.
yeah, it is a plane that, you know, has met with some sort of undesired event and there's an accident. When they retrieve the black box, then they can actually capture the data, right? Like the precise time at which the instruments fail. And that's how we can get this 0.8611 and all of those fancy figures in them. So that's the downside of it. Now, it is actually good for exam because they have actually asked that outright. They have asked, and I've actually seen the question here. They came out and they asked, I could probably try to do the question first. They came out and they asked a certain, you know, like which technique would be used to assess the effectiveness of mitigation measures. I could slip in some other words there. Mitigation means control measures, right? So which technique would be used to assess how effective a control measure is, and watch the word, after an event. Now, I mean, we didn't cover anything that was after, except in the ETA. We all know that risk assessments are proactive, hazards is proactive. We just covered that. There's a checklist that you go with and you see what hazards are on the plan. But the ETA, to be precise or to be fully precise, you need the quote unquote black box data then, right? You need to know the time at which the fire alarm panel, the fire alarm in the panel, when that stopped working, what caused it to malfunction, right? And normally those things are analyzed at the end of a fire per se, right? Anyway, this is what it looks like. And again, this is more for the folks who are doing the degree. you would not be required to construct an ETA. In an ETA, they say it looks like a family tree. You'll find it at the bottom here, but it's a sideways family tree. It doesn't start at the top then, if I can grab back my marker, right? But I wouldn't grab the marker because I'd have to go back and grab the cursor to move the slide. So let us get it back to that slide one time, right? So it looks like a sideways family tree, and you start off with the event, like if it's a fire, gas release, what again, explosion. You start off with what the event is. If I can remind you of what they said, what the ETA considers is the mitigation measures to prevent that, what you said. I'll say that again. An ETA examines the control measures to prevent what you say going to happen. So if you say it's a fire going to happen, you have to study the control measures you have in place. So if the control measure is a sprinkler system, somebody call in the fire department. Maybe you have a dilute system, water or powder. You know, I mean, they just have two branches there. They have 1, 2, right? So depends on how much controls you have in place, you can draw another branch up here, right? And the top part of the chart, consider when you say success, they consider if these things work. So if there's a fire, and I mean, they could have put in smoke detector. I could probably put 2 more branches in this anyway, but I'll stick to what they have, right? So if you have a fire and the sprinkler system works, that's what they mean by success. So the sprinkler system work, somebody call the fire department, then everything's supposed to be okay. See that one? So the top of the chart considers success, and then the bottom of the chart considers what happens if the sprinkler system did not work, but still somebody called the fire department. So there was a partial damage. And then of course, the worst case scenario, what happens if the sprinkler system didn't work, the fire alarm didn't go off, nobody called the fire department, system destroyed, right? So because again, like I said, it's not the degree and it's multiple choice, again, you could expect that, like which management technique examines successes and failures, which one is more objective, all of those kind of questions, and you will get it, right? Like I said, I do have Melanie with us here, and I don't know if I have anybody else who did the diploma, maybe with other places back then anyway. But in, so I'll grab the marker now. I think I showed you all this in class. With the calculation, though, when they examine this, like if this was to fail and they will send this to the lab and whatever have you, they would be able to figure out then like the percentage or the decimal point. I mean, you can convert it back to a decimal point at which something succeeded. If it's 0.08, they call to the fire department, 0.5. And then, like I said, this is how precise this is. To get the probability of it being okay, you have to add up these 2 here, which if you go back to the slide, you see they talk about calculations. Have no fear at the diploma level, and I guess at the real place of work, you could use a scientific calculator, right? So there's no fear for the actual calculation. The failures, right? It's more complicated. You know, the failures have a formula. It is actually 1 minus these numbers on top here for all of them. So we can call those numbers N. So the calculated failure rate, you have to say 1 minus 0.08. Now the reason I'm showing you this is to show you what those diploma students have to go through, and really not really for that, but to tell you how precise this thing is now. So 1 minus 0.08, you're gonna get 0.02, I believe. And you know, I guess the idea goes on, for this failure rate, this will be 1 minus 0.5, and this will be, my mistake there, trying to make a 5. This will be again 0.5. 1 minus 0.5 will give you back 0.5. Anyway, you get the idea that this thing is objective. If I can show you that anyway, this is the point of showing you the numbers, that this thing is precise, this thing is objective, this thing is the best way to predict what's going to happen. And for those who know now, that's not the end of the formulas, right? This formula here, this is the simplest of the formulas. All of the numbers you get here, now you have to take them and do something with them, and there will be numbers all here. Right. So you'll be here in the rain upstairs, right? Yes. Right, so I am broadcasting from upstairs, and so normally if rain falls, that you'll be hearing quite a lot on the ceiling, right? So hopefully you could hear me okay. I may just increase my pitch a bit so you can hear me quite okay. All right. Right. So that would have been the ETA. As I mentioned, you can go back and see that this thing was had calculations in it. You can find all of that here, binary logic, following logic, right? So I'll clean that screen there, right? So it is raining in San Fernando.
It was just raining here in Arima, but like it reached down by you.
Yeah. Right.
We hearing you though.
Okay, good. As I worried about that, I can probably close this window. All right. It may help us to an extent. All right, so we did that. This one, right, the failure mode effect analysis. Did this one too. I mean, I guess the safest thing with the read is to read, right? So I'll read because of the read, right? And I guess you all could follow because of the read. So failure mode effect analysis evaluates the way equipment can fail and the effect these failures can have. In an FMEA, each individual failure is considered as an independent occurrence with no relation to other failures in the system. So I'll have to lower my pitch now. Except for the subsequent effect the original failure may produce. FMEA identifies single failure modes that either directly result in or contribute significantly to an accident. FMEAs are conducted to improve the safety of equipment by identifying single component equipment and system failure modes, determining the potential effects on the equipment, system, or plant associated with each individual failure, generating recommendations for increasing reliability of the component, equipment, and or system. Doesn't seem to be getting any better. There are basically 5 steps involved in an FMEA process. Of course, it's more than 5 here, right? Break the system into component parts, determine how each component may fail, determine the possible effect of these modes of failure, consider how each failure mode can be detected, assess the consequences of the failure on the system or other components. And you have a chart of it here, right? I guess on the rain ease up, I'll come back and explain it a bit, right? But I guess if you can hear me, the main thing with an FMEA, right? The main thing with an FMEA, let me just grab the marker so you can still try to follow, right? Is that what they do, they take a whole system, right? And they break the system up into components, right? They will look at how the component could fail, and they will look at that failure on the entire system, right? So how the failure could affect that entire system, right? So you can think of it, you know, if you look at a car and you break the car into components, you look at the exhaust, you look at the transmission, let's look at the transmission. And if the transmission fails, what is the effect on the entire system? So that is what, in essence, an FMEA is. It is a study of components, parts on the entire system, right? I'll clear that there now. And you can see if you can make that out. on, just trying to grab back the cursor, on the other page. Right, so if you look at the page, you will see things like, you would see, I guess you have to go through this in detail, but you will see the components, right? That would actually be part of an entire system, right? But I don't want to do this one, especially with the rain, right? So if the rain is up, I'll come back. I'll try to kind of keep on because we have to read each piece in this, which would be a bit problematic. Once you get the idea, you can move from there, right? With an FMEA, they calculate something called a risk priority number, and that could be derived by saying severity multiplied by the occurrence multiplied by the detection rate. You'll find that here. They calculate something known as the risk priority number, this number to the side here, right? So again, because it's multiple choice, we could say that a question can be, which of the techniques then uses a risk priority number? Which technique uses a study of components? The answer would be a failure mode effect analysis, right? This one is the easiest one. So again, I'll read because of the rain. And this, I think, is just 1 or 2 slides long, right? So I'll take a read of this one. So what if analysis? The method can involve examination of possible deviation from the design, construction, modification, operating intent. It requires a basic understanding of the process intention, along with the ability to mentally combine possible deviation from the design intent that could result in an incident. I mean, that's a lot of words, right? Typically what they're saying, a what if analysis is a HAZOP. A what if analysis is a failure mode effect analysis, right? A what if analysis, if you go back and you see the word design, deviation, modification, all of those is covered in a HAZOP already. So a what if analysis is done in a HAZOP. Talking too loud now. All right, risk management tools. Again, this is something that I threw in here. This is not found in your textbook. You know, to talk about, you know, like which techniques that can be used, meaning that you could use for the risk determination, then you could use any technique. You could use a what if analysis, you could use the hazard, which is a checklist. You could use the failure mode effect analysis, in which you look at components. You can look at a HAZOP study, hazard and operability study. All right, so the concept of ALARP, I think we can probably cover this and possibly stop for today. I may mention this one because this is simple to explain. We'll probably stop right here. So we have 2 more concepts to go today. And hopefully I would be able to come across fairly well, right? And these were just tough to explain. So if it wasn't for the rain, I would not have been reading them. I would have just explained them, right? So anyway, I'll read anyway still. And I'll add the explanation at the end, right? So risk has been, I don't know if that's the first one. Okay, yeah, risk has been reduced. ALARP is about weighing the risk against the sacrifice needed to reduce it further. The decision is weighted in favor of health and safety because the presumption is that the duty holder should implement the risk reduction measure. To avoid having to make this sacrifice, the duty holder must be able to show that it would be, this is the key to this, grossly disproportionate to the benefit of health and safety or to the benefit of risk reduction that would be achieved. I would explain at the end, right? The key thing though about ALARP is that you must be able to tie in those 2 words with it, grossly disproportionate, because that's how you can tell it in an exam paper. Back to the slides, right? Thus, the process is not one of benchmarking the cost and benefit of measures, but rather of adopting measures except where they are ruled out because they involve grossly disproportionate sacrifices. Extreme examples might be to spend 1 million to prevent 5 staff suffering bruised knees is obviously grossly disproportionate. 1 million to prevent 5 staff members suffering bruised knees, right, is obviously grossly disproportionate. But to spend 1 million to prevent a major explosion capable of killing 150 people is obviously proportionate. I would explain at the end, right? In most situations, deciding whether the risks are as low as is reasonably practicable involves a comparison between the control measures a duty holder has in place or is proposing and the measures we would normally expect to see in such circumstances. For example, good work practices. Good practices is defined by the UK HSE as those standards for controlling risk, and the HSE has judged and recognized as satisfying the law. When applied to a particular relevant case, it is applied in an appropriate case in an appropriate manner. One more again. Examples of good practices may include the HSE approved codes of practices and guidance notes, industry standards and standards produced by the organizations or by organizations such as ISO, International Organization for Standardization, right? So I guess I have to explain all that as the end of it. The whole thing here they was saying, right, is that, back to the first slide, was that in process safety, for those of us who know the law of Trinidad and Tobago then, and even regular safety, there is a duty, let me just grab the marker better, sis, right? There is a duty in the OSHA here in Trinidad to reduce the risk to what they call so far as is reasonably practicable, right? I don't know if anybody familiar with this phrase on the OSHA. So far as is, right? Reasonably practicable. Now what is said in process safety, they're not saying that. They didn't say so far as is reasonably practicable. They have a new level of duty, something called as low as is reasonably practicable, right? As low as is reasonably practicable. And again, the reason for that is because the risk associated with process safety is much more severe, right? It's supposed to be as, if you're writing it down, this could save me this stress, right? This supposed to be so far as is reasonably practicable, the same RP to the back there. But in process safety, they don't go so far as is, but we go as low as is, right? And this here is, I think it eases up a bit. This is a stark difference between level 3 and level 4. In level 3, whenever they say, and like I said, our OSHA here, this is a regular city, whenever they say, as far as is reasonably practicable, what the employer could have done, for those who remember doing it, and I do have, I think, Indira and Sharon, and we have some persons that, at least you are the face that I'm seeing, right, on my screen, who did the recent IOSH Managing Safety course. So if you would have studied our law and regular safety, when they say as far as is reasonably practicable, the employer, anybody know what they're trying to write here? Is supposed to put what here? Cost, time, and what? Anybody remember it? Cost, time, and? People still waking, or you fall asleep in the rain, right? Cost, time, and effort, right? Yeah, right. So anyway, the point I'm trying to say, in normal safety, when the employer have a duty now, and they say the employer is to provide safe, access and egress, what the employer does do, if you didn't know this, the employer, and I mean not the employer, yes the employer, but also the law of the land, right? It allows the employer to only provide for you based on the costs they have, the time it will take, and the effort it will take them to reduce that risk. I don't know if you know that. That's the law of the land in Trinidad and Tobago and the UK and in America, right? That the duty is so far as is reasonably practicable, meaning that if you had asked your employer for to purchase a new piece of equipment, maybe some sort of pillar drill or pedestal drill, something with a guard or something like that is the idea I want to convey, and they don't have the money, and they could prove that, they can prove because of the economy, we don't have the money to buy a better pedestal drill at the moment, but we're trying to maintain this one, then the employer doesn't have a duty to buy a new one, right? The employer will balance what you are saying against cost, time, and effort. Now that is level 3. What you see here, and this is what I wanted to explain when the rain start, right? What I wanted to explain was that in process safety, that's not the case. In process safety, what they're saying, as low as is reasonably practicable, means that you are not to consider the cost, time, and effort. Well, I mean, not to consider it alone. You are only to consider cost, time, and effort if you can prove that what they are asking for, that guard there, that machine, is grossly disproportionate to your cost. Simply put, what this means is that, to boil it down, what it means is that the employer should spend the time, should spend the money, and should make the effort to like ventilate a tank there, right? They should do everything within their power. So it's actually the flip of level 3, when in level 3, you could have said, they could use cost, time, and effort as an excuse then not to do it. With ALARP, it means the opposite. It means that they have to spend the time, they have to take the money, they have to take the effort to put the measures in place, because if they do, the outcome could be quite disastrous. And the only excuse they can have is if excuses like these, and have to change the cursor, right? When you have the marker, the slide doesn't go, so I have to come back and change the cursor. So the only excuse you can say is something like this, then is like if something is being asked for, but what is being asked for, like the example I tried to create here, to spend $1 million to buy something to prevent people from suffering bruised knees, that may be seen to be grossly disproportionate to control the risk. That's the only excuse they have there, right? So how to bring this down for exam? The thing though is that exams tend to be less complicated to what I have tried to do there. There was an exam question that said, what must the employer consider in assessing risk to as low as is reasonably practicable? And the only answer they had that made sense, well, all the answers had one of these now. All the answers had cost, time, and effort, or cost, task, and effort, or consumer time and effort. So the only one that made sense was cost, time, and effort. But I think what you have to know here, because that is a multiple choice question, what you have to know is that the employer have to consider those and just spend it. That's the point. They have to spend the money to reduce the risk, as opposed to level 3 or the OSHA. We can't use it as an excuse, but the money has to be spent. The time has to be spent. The effort has to be made to reduce the risk, unless it is grossly disproportionate, right? As I would say again, the exam question was less complicated. Again, because it's multiple choice, it simply asks what must be considered. And the only thing, they had the 3 words, but it was all messed up. They had consumer, they had task, they had different words for, you know, that starts with C and T and E. So the only one that made sense there was cost, time, and effort. But you could look out for grossly disproportionate. If there was to bring another question, like what exception then? What is the exception for an employer not providing something in process safety? The answer, it must be beyond the money there, like typical money. And if you wondered why I went to talk about standards, it was like beyond a standard, beyond what would have normally been produced, or beyond an industry norm. This is the point of putting all of these slides here, right? And if you look at it graphically, we almost finished, right? If you look at it, there's one more thing to go, which is the hierarchy of controls. I'll let you all know that already, right? Let me just try to kind of clean that, clean the slide there, right? So if you look at it graphically, what they say about ALARP is that it is economical. It is reasonable, then it's going to break the employer's pocket, right? It did not require, ALARP did not require the employer to reduce the risk to 0. That may not have been practical, plus it may have been expensive. This is the point of the graph, right? But it did require the employer to justifiable reduce the risk to as low as is reasonably practicable. Spending money, look at their cost of security, spend the time, make the effort. It is still seen to be reasonable, unless if what is being asked for is a lot of money, like $1 million, and that is just going to prevent minor car park accidents on your premises anyway. So that may seem to be an exception where the employer can say that they would not provide this because it's too much money to prevent these minor car park incidents anyway, right? All right, so last one, as a lot of you all would be familiar with the control hierarchy. There's about 3 slides with it, so I wouldn't even read because the rain has stopped. I would just tell you 1, 2, 3, well 1, 2 in fact. So the point about the control hierarchy, a lot of you all know, is that it starts with elimination and ends with PPE. A lot of you all would know that. PPE is last, even though, you know, as you enter most companies, you will see PPE, the sign that says PPE must be one beyond this point. So a lot of people think PPE is first, but it's not really first. PPE is the last measure. Again, the only thing you have to consider though is that what we are looking at is a level 4 course, process safety management. So we kind of have to tweak it into process safety. So what you have to know is that in a normal job then, I mean, somebody could say, you know, well, we could reduce the noise or we could get rid of the noise by turning off this machine, by turning off this generator. Now in the process field, we are not entitled to that because process plants are noisy. Process, you know, equipment and machines and flare stacks and, you know, manifolds and stuff, the nature of them is that they are high risk. So the point I was trying to say here is that even though elimination is first in, you know, regular safety, you could eliminate housekeeping issues and whatever have you, but you wouldn't be able to do that in process safety. So in process safety, the first element in the hierarchy of control, I think we looked at a question on this, is what is called inherent safe design. And that means then that the designers eliminate out the hazard in the first place, right? If you're not quite sure, and I'm kind of running out of time, if you're not quite sure what I'm talking about, you could think about, if you know anything about like spark resistant tools, and you have better names for them. You have different classification of tools then that are called intrinsically safe tools that you can use them and they do not produce a spark. If you have any background in electrical, I know Jameson has a background in the field of electrical work. You have insulated tools and you could actually work live. You could work live. You could take, you know, a live socket down, and because you are using insulated tools, you will not get shocked, right? So this is the idea that in the field of process safety, we would use tools and equipment that has been designed safer. So if you ever see this as an option, and if there was a question, I wonder if it's here. It is here, it's just where it is, right? If I didn't pass it already, right? That there is a question on your paper that spoke about what is the best strategy, and the answer they gave was inherent safe design, and that is the better answer because, as I mentioned, it is not you going and now putting measures in place, but the manufacturers, the designers of this thing would have put those control measures in place. Nonetheless, I'm going to just read out the first word in the hierarchy. Inherent safe design, by the way, is your answer for any hierarchy question. Prevention, detection, control, mitigation. The highest priority must be given to inherent safe design and measures to prevent and control major accident hazards, right? Inherent safety is a concept particularly used in the chemical and process industries. An inherent safe process has a low level of danger even if things go wrong. It is used in contrast to safe systems where a high degree of hazard is controlled by protective systems. This thing is intrinsically safe, spark resistant, right? And again, some of those things are diploma type work. So I don't want to go into it, but know that you have different types of equipment out there, type E and type C and whatever have you, that these things are produced to be safer anyway. An inherently safer design is one that avoids hazards instead of controlling them, particularly by reducing the amount of hazardous materials and the number of hazardous operations in a plant. So I'll stop there for today. We're going to stop right here on asset management, well, asset integrity life cycle anyway. I want to go back. I think there was that question here, and I think it was right there. No, you have to look through, I guess. It is there. I don't know if I passed it when I was going through, but that question is there. Which of the following techniques is the best? And the answer was inherent safety design. You know what? As we have our books and we have about 5 minutes, you know, just in case you forgot, to the end of your chapter, I'll find the page for you. There are questions at the end of the chapter. This is page, we could just throw in tuna, right? This is page, it looks like to me, page 54 or 55. I'm sure I'll be able to find it there faster than trying to go up and down with the slides.
54.
Yeah, 54, right? Okay, thanks very much. Right, yeah, my lighting is with the rain, I guess, right? Anyway, you want to, I guess you can look at some of these home. You know, we have looked at some in class. Let's just do 1, 2, and 3 because of the time, and I really wanted to still address you with some issues anyway still. So number 1, you see if you're coming with the answers, right? By the way, the answer is somewhere in your book. I think it's on the other page, but don't look at the other page just yet. So number 1, process organizations have in place a wide range of mitigation measures designed to reduce the consequences of a major incident. You all seen this question, right?
Yes.
Okay, now the reason why I asked it is because remember we bought a next shipment of books. I was wondering if NEBOSH changed anything in the book. Now, remember the books that you all got in February? The first of the students got some books, but then we had to order another shipment that was stuck in the port or something. Anyway, if I say it's the same person file, it means it's the same. Sometimes some from one sitting to another sitting, they would include new questions in it. So that's what I was asking, right? Anyway, which risk management technique is especially suited to assess the effectiveness of these mitigation measures? Well, again, what do you think is the best answer there? Process organizations have in place a wide range of mitigation measures. Mitigation means that control measures. Which technique examine control measures? There was only one. It was the? Anyone? You could shout it. We may have looked at this in class already. You could give us those of us who don't have the mic on, in order for me to listen to this, put your mic on a bit.
Inventory analysis.
Inventory analysis. Okay, thanks very much, right? Yes, excellent. Number 2, which of the following is an example of planned preventative maintenance? Now we didn't, this is actually under asset management. You notice that was chapter 2. So then if you want to look at it still, which of these would be planned preventative maintenance? Meaning like, for want of a better phrase, a shutdown. You know, the fun thing about multiple choice I said is that the answers are all there, and even if you didn't pick up your book, which we are picking up today, the answer is right there. Which of these is an example of planned preventative maintenance? Daily visual inspection of a process plan. Now that's not going to be planned. The daily is more the idea of shutdown, right? Daily means it's more like continuous monitoring, and it isn't really like planned preventative maintenance. Anybody have the answers? Yes?
Greasing of pump bearings.
Right, greasing of pump bearings. So if your plant is down, I mean, you put it down, planned, listen to it, you put it down, planned preventative. You put the plant down for a bit, 2 weeks, then you do all of those, you know, regular mechanical, you know, work on it. Number 3, quantitative risk assessment. I mean, this is so easy. And as I said, I know some of you all, I know people like Melanie and Sharon, and I know even Jameson, who doesn't have too much of a safety. I know you all, and you all will be able to do this exam in less than a half an hour. I have had people done it in 15 minutes, half an hour, 20 minutes, etc. Right? Anyway, this one, quantitative risk assessment differs from qualitative risk assessment because the quantitative is more what?
Objective.
Objective. Okay, good. Right. So I'll stop there for today. So let me first of all express some degree of appreciation for you all responding so well to the class. Now, the reason is because now 3 of our classes, as I mentioned at the start of the, in fact, let me stop the recording because this will cause this thing. I'll stop the recording and I would keep talking to you, all right?